In this video, I am going to start carbon and its compound. This chapter I have selected from standard 10 board. Apart from that, it is also a base part of standard 11 and 12. So, from its name it is clear. Here we are going to study about carbon and its compound. So, the topic is carbon and its compound. In this video, I will explain, or in this chapter we need to explain elemental form of carbon as well as its combined form of carbon. Carbon present in its elemental as well as its combined form. Food, medicine, clothes, drugs, dyes, all are the versatile examples of versatile nature of the carbon. So, carbon, here the first point that I want to highlight, that it is present in the elemental form, and second is it is present in the combined form. Second thing that I want to explain, that 0.02% of carbon, very important, only that much amount of carbon present in the earth crust. Very important information. And that carbon present in the state of minerals, earth crust. You can see that it present in the form of carbonates, it present in the form of coal, petroleum. This part, 0.03% carbon, is present in the atmosphere, and it is present in the form of gas, carbon dioxide gas. So, this is the point that in this chapter we are giving importance to carbon. Is there any special property that is different from other elements? So many elements are there in the periodic table, but we are focusing only on carbon. We are not showing oxygen and its compound. We are not telling nitrogen and its compound. We study oxygen, nitrogen, phosphorus, that is group 1, group 2, group 13, 14 as a common part, as a S block, as a P block, as a D block, as a F block, but we never study a single element as a branch of chemistry, and that is called organic chemistry. This part, this chapter, carbon and compound, its name is given different in different part. For example, in CBSE board, it is called carbon and its compound, whereas in ICSE board, it is called organic chemistry, whereas in 11th standard, hydrocarbon and properties of hydrocarbon, some basic property related with hydrocarbon. So we are using different names, but the theme is single, the purpose is single, that we have to focus carbon, its versatile nature, why it is so important, and what are the important properties that it will show. Second thing here, that we have already explained bonding. This is very important part. In chemical bonding, I have explained that 3 different types of bond. Here we have to focus only 2 type of bond. Ionic bond. This is very important bond. In ionic bond, we have studied that compounds are prepared by transfer of electron. Second thing is that high melting and boiling points, they are good conductor of electricity. Here one table is given in NCERT NCERT book, that is very important table, very important information. If you focus this information, then it will be very easy to give a final conclusion about carbon and its compound. This is ethanoic acid. This is CH3 chloroform. This is melting point and boiling point of hydrocarbons or compounds of carbons are given as a table in NCERT book. That is very important information. And the last is methane. This information is very important. If you see the melting point and boiling point of carbon compound here, carbon and its compound, then you find that their melting point and boiling points are not very high. Just this table says it is in Kelvin. Temperature always we take it in Kelvin. So here they are also not used as a conductor. So the point is that what is the bond making capacity? How will carbon make? Here in ionic, I have explained that either transfer of electron. I have explained that here transfer of electron takes place, and that transfer occurs either in the form of gain or loss of electron. That is very important. When there is a transfer of electron takes place, for example NaCl, then here Na loses its electron and turns to Na plus ion. Cl gains electron and turns to Cl minus ion. So in one case there is loss of electron, another case there is a gain of electron. Just we consider about carbon. If carbon atomic number is 6, it has 4 electron in the L cell. If it could gain 4 electron, just we see this condition, this criteria is fulfilled by carbon or not. If it could gain 4 electron, then it will have 4 negative charge. That means its proton will be 6, but its electron is 10. So here it would be difficult for the proton to hold 4 extra electron. That is, to attract this 4 extra electron, it will be difficult for proton to attract this 4 electron. So this is not possible. If it lose 4 electron, then it will be 4 plus. So here proton will be 6 and electron will be 2. In this case also, large amount of energy is required to remove electron from the control of nucleus. We know that nucleus has positive charge and valence electron has negative charge. So there is a force of attraction between the opposite charge, and this force of attraction will prevent loss of electron, 4 electron. So in case of carbon, these two problems has been solved because it will share electron. Very important information. It will neither lose nor gain electron. It will share electron from its adjacent atom. This is very important point. So in order to share or in order to share, I have already explained in bonding, whenever there is a share of electron takes place between two or more than two bonded atoms, this is known as covalent bond. This is known as covalent bond. So before going to show the nature of covalent bond, I just want to explain one two examples that is given in NCERT book. For example, in NCERT it is given just we need to understand before going to explain the compounds of carbon. Here some examples are given in the textbook and I want to explain that. First is the hydrogen, second is the chlorine, dot structure. First is the H2, second is the chlorine, third is the oxygen, fourth is the nitrogen, fifth is the carbon dioxide. So if we see the structure of hydrogen, then hydrogen atomic number is 1 and its electronic configuration, it has only one electron in its casing, and to complete its stability nearby its inert gas, its nearby inert gas is helium. Its stability is 2. It has 2 electrons. It is stable. So if hydrogen acquire 1 electron or share 1 electron with other hydrogen, suppose it has 1 electron, and if it share 1 electron with other hydrogen, then it's this duplet configuration. We say this word, for 2 electron we use the word duplet, and for 8 we use octet. And both are required for stability. So its stability will be fulfilled. So we can say that hydrogen share 2 electron. There is sharing of 2 electron takes place between 2 hydrogen atoms to become stable. To take example of chlorine. Chlorine has, if they see the structure of chlorine, then its atomic number is 17 and KLM. It has 7 electrons in its M cell and its nearest group is argon, that is 18288. So it needs 1 more electron. So here chlorine share 1 electron with its nearby chlorine atom and it will fulfill its octet. This. So we can say that chlorine single bond single. Same way we can draw the structure of oxygen. Oxygen has 6 electron as a valence electron. 6 electron at a valence, so it needs 2 electron to become stable. So 2 electron is going to be shared between 2 oxygen atoms. When there is sharing of 2 electrons, single bond, and when there is sharing of, this is not required. After dot structure you remove this. So when there is sharing of 2 electron, then single bond. When there is sharing of 4 electron, there will be double bond. This way you can draw. Same nitrogen, N2. Its valence electron is 5, so it needs 3 electrons. 5 and 3, 8. So remaining 2 will be outside. and the nitrogen has also. Now this octet has been fulfilled. So we can say that N triple bond, and for 3 electron triple bond formation takes place. In case of CO2, oxygen will share its 2 electron. We have already got this information because it values statistics. Carbon has 4 electron. So here octet of oxygen has been fulfilled, as well as octet of carbon has also been fulfilled. So here we can say there is a double bond formation between carbon and oxygen. So these are the information of other elements, and carbon also share with other. So first we need to know the versatile nature of carbon. Why carbon is so much important for us? Why we have given so much value to carbon, and we have made a separate branch of chemistry that is fully based on carbon. That is very, very important. We need to understand this versatile nature of carbon. So there are two important properties of carbon that is going to be very, very important, and that makes carbon very special, and that these two important properties, the first one is a very, very important point is catenation. Very, very important. Carbon can join with carbon, carbon can make bond with carbon, and it forms a long chain. Very, very important information. It forms long chain. Second, it forms branch chain also. Not only long chain, it has tendency, it has capacity to form branch chain. Third is it can present in the form of ring also. If we see the structure, then here see, this is the nature of carbon. It can join with other carbon and form a long chain. Not only that, it can make branches with the carbon also, here like this. And carbon can form a ring also, like this. Like this. Those who are standard 10 students going to give board exam, for them this part plays an important role. For a standard student, 11th student, this is going to be base. This is the peculiar. No other elements in the periodic table who can make chain, who can make branch, who can make cycle. That is ring. This is the property of only carbon. Then the second property, that is here the chain formation takes place between carbon. Apart from that, carbon makes bond with other element also. Like it makes bond with oxygen, it makes bond with nitrogen, it makes bond with carbon sulfide, it makes bond with hydrogen. This is called multiple bond making capacity. Very, very important. Multiple bond making capacity. Not only with a singular carbon, it can make bond with other elements also. Like carbon dioxide, we can say carbon monoxide, CO. This is bond, nitrile bond, CS2, carbon hydride. So many compounds of carbons are produced, and that's why we are giving its importance in chemistry. Second thing is that is tetravalency. Tetravalency. As we know that valency is the combining capacity of an element. It is the bond making capacity of an element. And if we see the structure atomic number of carbon, then we find that its atomic number is 6. Atomic number represented by symbol Z. It always written below here as a subscript, whereas mass number we write as a superscript. This. So its electronic configuration here 4 electron is outermost orbit. So tetravalency means it can make 4 bond. Carbon can make 4 bond, and suppose we have to fill hydrogen here. So this carbon has single bond, so we can fill here 3 hydrogen like this also, or like this also. Like this also. This is the method. Here 2 hydrogen, 2 bond, 2 hydrogen. Here 2 hydrogen. Here 2 hydrogen. Here 2 carbon, so 2 hydrogen. So we can write condensed form. This is called condensed form. This is the condensed form of. This is the condensed form. So this is the important property of the carbon, that it can make maximum 4 bond. Suppose we want to see in methane. I will explain the classification of methane. In ethane here. In ethyne. You have heard this name, ethyne. In ethene. Here. So single bond, double bond, triple bond, all types of properties present. One thing here I want to remind, that this catenation property is for carbon only. Sulfur, silicon belongs to group 14 element. It is a carbon family member, and it has also tendency to make long chain with the hydrogen, but it is highly reactive, so unstable. Carbon is a stable molecule. Due to its smaller size, this bond is going to be very strong, so it is stable. That's why so many compounds are formed in the chemistry, and there is a requirement of a new branch of chemistry, that is organic chemistry. So these 2 important property of carbon, these 2 important versatile nature of carbon. First is the catenation, where carbon can make branch, carbon can make long chain, carbon can make ring. Then second is tetravalency, that its maximum bond is 4. It can join with other carbon, it can make bond with single bond, double bond, triple bond. So all the different types of bond formation takes place, and this peculiar property of carbon is due to its small size. That's why we can say the versatile nature of carbon makes it special, makes it unique. Now next thing is that we have to classify carbon. We have to classify compounds of carbon. So how will we classify carbon? So carbons are classified or hydrocarbons. So here carbon is compound. We are going to study about hydrocarbon. We are going to study about hydrocarbons. Here we are going to study about hydrocarbon. So we can say carbon and its compound. What we are going to study? We are going to study about hydrocarbon. There are two different types of hydrocarbon. One is called saturated hydrocarbon and another is called unsaturated hydrocarbon. There are two types of hydrocarbon we need to study in this chapter. First is saturated and second is unsaturated. So saturated hydrocarbons, you can say that it is a type of hydrocarbon where single bond present between two carbon atoms. So this is saturated, and if double bond or triple bond present between two carbon atoms, then this is called unsaturated. In this category, we will keep a hydrocarbon, and that hydrocarbon is called alkane. It is made up of two words. First is alk and second is ane. So I will explain what is the actual meaning of alk and ane. Here, double bond is called alk plus ene, that is alkene. Here, triple bond is called alk plus ine, alkyne. So alkane, here word alk. Alk word we use for, the word alk is used for alkyl groups. It has come from name of carbon. For example, number of carbon is 1, then this is called meth group, and its alkyl part is CH3. Alkyl part. I will explain what is alkyl. Here methane. So meth is there, and when we make formula of meth with ane, it becomes methane. So we put the formula. For this we need to apply a formula CnH2n plus 2. Here for this I am writing here carbon-carbon double bond, that is alkene. Actually I don't want to explain this topic in detail because I have already given video related with nomenclature of hydrocarbons. So I will go in short, and you just, if you have any confusion, you can check it from other video. But this you need to understand the basic difference alkyne here. So this structure is here CnH2n, and this is CnH2n minus 2. So if we add plus 2, though 2 hydrogen atom, then we get alkane. If we add 2 hydrogen in alkene, then we get alkane. And if we remove 2 hydrogen in alkene, then we get alkyne. And for number of carbon is meth 1, so its formula will be CH4. From meth it word become meth, and it become methane. No compound formation takes place for this. No compound formation takes place for this because it needs at least 2 carbon. Minimum 2 carbon is required for alkene. Like this we can make. Just I want to remind, for 2 we use eth, for 3 we use prop, but, pent, hex, hept, oct, non, dec. These are the names that we use for number of carbons, and we apply this in the symbols. Basically it will be better that suppose if you have to make formula of pentene, or suppose you have to make formula of pentyne or pentane. So better first we focus on ene. C5H10. Pent means number of carbon 5. So it will be C5H10. You add 2 hydrogen, you will get ane. That is pentane. C5H12. This is the pentane. And you remove 2 hydrogen, then you will get C5H8. It is pentyne. So I suggest you that instead of focusing all the 3, it will be better that you focus on alkene part. While making the formula, suppose you have to make formula of hexane. So first you make hexene, C6H12, and then you add 2 C6H12. So it will be easy to memorize the topic and to explain the compound. Now here, so we have got, suppose we the word is pentane. Suppose I have used the word pentane. So we will write C5H10. Sorry, C5H12. This is pentane. So this is called molecular formula of the hydrocarbon. Very, very important. The formula, the symbols that I have written, when we fill the hydrogen over there, then we get a formula that is molecular formula. So hydrocarbons can be represented by two parts. First is the molecular formula, second is its structural formula. So in the exam questions may be asked that write the molecular formula of the following compound, write the structural formula of the compound. Then one more information, that is condensed formula. It's condensed form. I'll explain. Just I am going to explain the topic, the part that is going to be asked in the exam, the detailed part of the hydrocarbon organized table I have already given in the organic chemistry part 1, part 2 video I have already given. In that video you can check what is the symbols name for n is equal to 1, 2, 3 up to 10. Then how will we make this formula with A, in, I. All information I have already given in my previous video. So I don't think it is important to explain here. Here only I will explain those points that are not given in that video. So don't think organic chemistry it is very easy. I am telling you it is a very difficult, complicated part. Up to 10th standard, it is, you can say it is a part of chemistry, but in standard 11, it will become very difficult. So, if you will focus one by one, it will be easy for you to understand the topic. So, here, the first thing is the molecular formula of hydrocarbon. Second is the structural formula of the hydrocarbon. This structural formula can be expanded form or it can be condensed form. It depends upon you. For example, suppose you have to write molecular formula of hexene. Then you remember hexene in first hex, that is carbon 6, E 12, A 2 more 14. This is the molecular formula of hexane. To make its structural formula, we will see here this point, ane. Here ane means single bond. That is a very, very important information. You remember, ane means single bond between two carbon atoms. Ene means a double bond between two carbon atoms. And ine means triple bond between two carbon atoms. So here, this is the 1, 2, 3, 4, 5, 6. Now you feel hydrogen. See, 4 bond is required. So 1, 2, 3, 4. Like this you feel. You cannot be more than 4. This is tetravalency. Put hydrogen over there. This is the structural formula of that is in expanded form. We can write it in condensed form also. In the exam, I suggest my students to use condensed form. 1 bond is there, so 3 hydrogen. 2 bond is there, so 2 hydrogen. 2 bond here is 2 hydrogen. 2 bond is 2 hydrogen. 2 bond is 2 hydrogen. 1 bond is there, 3 hydrogen. So this is the condensed formula of hexane. So these all information that is given in the chapter. After that, here the next topic that we have to focus is homologous series. Very, very important point. Homologous series. Very, very important. It is, we can say, a group of organic compounds where they have a common structural formula. They have a common chemical properties. One point also you can add, they have a common functional group, because whenever we are going to make homologous series, this is applied for the same functional group. We cannot find homologous series of alkane. We cannot compare homologous series of alkane with alcohol, alcohol with carboxylic acid. We need same group. So homologous series structural formula, same common structural formula, chemical properties, common functional group. Suppose here I am writing about this is methane. We need to find its next homologous. Here the point you remember that compounds having same molecular formula, same structural formula, same chemical properties, and the successive member differ by, that is very important point, successive member differ by CH2 group, or you can say 14 amino. That means if we want to find next homologue of methane, then we need to add 2 CH2 group. And what is the difference between methane and its next homologous molecular mass? Then we can say it is 14 amino difference. For example, suppose this is methane. Its next homologue we can find by adding CH2. So it will be C2, here C2H6. Its molecular mass 12 on plus 4, that is 16. Its molecular mass 24 and 6. 30, make a difference between 30 and 16. You will get it is 14. It will be 14. So the next homologue. One thing I want to explain, if you have taken carbon first, then its next homologue cannot be carbon third. It always be carbon second, 2 carbon. Then its next homologue again we add CH2, then we get C3H8. Here also the molecular mass 30 and its mass difference will be 14 units, you can check. So here again 14. So this way we can say that homologous series are organic compounds or group of organic compounds having common structural formula, having common chemical reactivity, and the successive member differ by CH2 group. But in the exam, questions will be asked in different part that I will explain how the question will come. Suppose the question homologue series is question can be asked first, write next homologue write homologue of first C3H7OH CH3CHO HCOOH. Suppose this is the compound. I have not explained functional group, I will explain that. But first understand how to find next homologue. Just you add CH2, this part. Don't use this part. So it will be C4, 7, H9, OH. This is butanol. Here again CH2, mind it, you have to add here this part only. Functional group, this is functional group. I will explain this is functional group. Don't use this functional group, you add here. So it will be C2H5, CHO. Here it will be CH3 C double bond. So in this way we can find the next homologue of the given compound. Here one two question I want to discuss. That is very important. Some questions are given and these questions are going to be very important to enhance your knowledge. That is very important. So I want to write this in short form. I will not explain the entire part. Just in short I will explain this question so that you can apply the concept that I have given. That concept you can apply in the form of formula, in the form of equation, in the form of question. That is the questions in CBSE board also. Some questions, advanced questions comes in the board exam. 70 to 80% question you will get from NCERT book. Some question will be hidden part. That is very difficult for students to judge. So that's why I want to give some information. Question part. For example, here there is a question that give at least one example of a cyclic compound with single bond. Cyclic compound with single bond. First is the here cyclic compound and having single bond. So you can write this. What is the name of this? Here 4 carbon is there. So you can say it is cyclobutane. Cyclic compound with a triple bond. Sorry, cyclic compound with double bond here. Second is cyclic compound with double bond. So here we can use this. So how will fill hydrogen here? This carbon, for this carbon, here 2 bond is there, so 2 hydrogen, this carbon 2 bond, 2 hydrogen. This carbon has 3 bond, 2 and 1 3. So here H hydrogen, 1 hydrogen. This carbon has 2 and 1 3 bond, so single hydrogen. Like this we can fill. So its name will be cyclobutene. Next question is given here. The part of one member of saturated hydrocarbon and unsaturated hydrocarbon. I think this is easy. Saturated is methane, ethane, propane, butane. Unsaturated is ethene, propene, butene, hexane. Anyone? After that, the next part that we have to discuss is the functional group. Functional group is the atom or group of atom. It is atom or group of atom which can specify a compound. Specify a compound. We are using word alkene. Ane is there. We are using the word alkene. Double bond is there. We are using the word alkyne. Triple bond is there. We are using alcohol. So here different functional group. Aldehyde. Here different functional group. So the types of functional group is, it is very important. Here name, here symbol, here its suffix, because here till standard 10 you have to focus only the suffix part. You do not discuss the prefix part. Here one thing I want to explain that is very important, alkyne group. Unless we will do this part will be not will not give confirmation. Alkyl groups means removal of one hydrogen from alkane. Suppose this is the alkene, and if you remove one hydrogen, then you get CnH2n plus 1. You remember CnH2n plus 1 is the formula, molecular formula of alkyl group. Suppose you have written C2H6, it is ethane. So if you remove one hydrogen, this is C2H5, this is ethyl. The most common is methane that we will use in nomenclature. If we remove one hydrogen, this is CH3, this is methyl. This is I group. Here ethyl, here methyl. So here we have to focus only the suffix part. Suffix parts are those functional groups, those parts which are used after the name of parent carbon. Here the word is suffix and prefix. Two words we will use. Prefix word we will use in standard 11, not in standard 10. For example, OH group. OH has suffix group ol and prefix, suffix group or and prefix is hydroxy. So that we will use in standard 11, 12. Till 10 standard we use only suffix. So suppose the compound is this. So we will use 2 carbon is there. So 2 carbon we use word ethane and you add suffix ol, remove E of the alkane and add ol. So it becomes ethanol. So after hydrocarbon we are using functional group. That's why suffix. But if you have to write name of this compound, just I want to explain for those students who are in standard 11 and their base is not good and they are confused about suffix and prefix. For them I am explaining. Suppose this is the compound and here this is the powerful functional group. In standard 11 book there is a priority group, superiority group that is given, that which one is a powerful functional group. So this becomes suffix, here it will becomes prefix. This group becomes suffix and this group becomes prefix. So we will say that this is hydroxy. This is hydroxy. We will say numbering start from here. So it is 2-hydroxy butanoic acid. So prefix word we use when there is another functional group also present, multiple functional group present in a given compound and one compound is powerful. So powerful group is used as a suffix group and the remaining functional groups are pronounced or named as a prefix group. So here this information I have made. So here the first part is the alkene double bond symbol and it is E. Alkyne triple bond, it is I. Alcohol OH ol. Aldehyde CHO al. Ketone CO ol. Carboxylic group COOH oic acid and halo group. So it will be halo means X, fluoro, chloro, bromo, iodo, and here it is used as a prefix. This group always uses a prefix. This is used as a prefix, no suffix. Here it is a prefix. Halo group always uses a prefix. Its name is taken before the name of the parent carbon chain. So these are the information of the functional group. So up to standard 10, till standard 10, we have to see only these functional group and you have to go in detail only about this functional group and you have to focus only the suffix part. You don't need to discuss the prefix part. Only the halo group is used as a prefix group. So here first I will explain the nomenclature part. Then after that I will explain isomerism, one most important part of hydrocarbon. That is very important, isomerism. What is isomerism? And then after that I will explain the preparation of the hydrocarbon, its preparatory part. That is very important. So here the first part is nomenclature part. Nomenclature part. So suppose here the compound is given and you have to write its IUPAC name. Suppose this is the compound given. This is the compound. This is the compound. So whenever we are going to name IUPAC name, the word is IUPAC name of a given compound. This part is very important, not only for board 11, 12, but for competition also. That's why I am telling you, those students who are standard 10 and they are willing to take science in standard 11, 12 or for medical engineering, please focus this part, because in GMAINS or in the advanced or in the NEET exam, one question comes from the nomenclature part also. That is very important. So here the first rule is the select the longest carbon chain. And whenever you are going to write IUPAC name of any compound, you have to select the longest carbon chain. You have to choose the longest 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. So this is the longest carbon chain. This is the first information you must have before naming of a compound. Second thing is the numbering. And numbering, I am just writing its short form from branches side. There is a word, what is branches? See this part. The part that is not going to be taken as a longest carbon chain. Here, suppose this is the longest carbon chain. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this is the longest carbon chain. So the part that has been excluded from the longest carbon chain, these are called branch. And when we are going to number the functional compound, then we will give priority to these branches. That is numbering from here, from this branch will be 4, here will be 3. So we will use this from this side. So that branches occupy minimum position. Their position should be minimum, least. So this is the compound here, 1, 2, 3 here, 1, 2. So and 2 branches are there. So this priority, this is given. Suppose here multiples are there. So you have to take this, and their position should be minimum. This is the compound. After that, branches, name of branch are taken first. Name of branch with their position. That is important. Suppose here this is the CH3, putfil hydrogen, CH3. CH3 is a methyl group, so its position is 3, 4. So first we write 3, 4 number, their position, and 2 same groups are there. So for the same group we use di. If different group will be there, then we will use separately. But if the same groups are there, we can take together and we use the word di. So here di, what di? Di is a methyl. So dimethyl heptane. Here again 3 branches are there, all are in the same category, methyl, methyl, methyl. 1 carbon means methyl, 2 carbon means ethyl. So here we can write 2, 2 and 5. Here we use trimethyl. Trimethyl heptane. This is the information. So in this way we can write the IUPAC name of a compound, but if there is a functional group in the compound, suppose the compound is, this is the compound. In this case, we have to take numbering from the functional group side. This rule will change from branches. So fourth is, if functional group present, then numbering from functional group side. That is important. So here we will number from this side. 2 methyls are there. So we write 4, 4 dimethyl. 5 carbon is there. pentanol. One position is there, so no need to mention one pentanol, or better you write one pentanol. Suppose this is the compound, another compound. Here the functional group is considered as the first carbon. That is important, very very important, that in some cases we have to give name of, we have to number the functional group carbon also. That is important, very very important point. Suppose the compound is this first. Second is this. Third is this. Here numbering will start from here only. We can start from here. This carbon is considered as first carbon. This carbon is considered as first carbon. Here functional groups are also named. That is important information. So the fifth point for carboxylic group, aldehyde group, ketonic group, functional group carbon is also numbered. Numbering will also take place from functional group carbon. And this is important information. When there is a carboxylic or aldehyde, they always be considered as the first carbon. They always be considered as the first carbon. So here it will be 3-chlorobutanoic acid. Here 2,3-dimethyl and 4 carbon is there, so butanol. Here 4,4-dimethyl and then 5,2-pentanol. You have to mention the position of the ketonic group. So when you get question based on nomenclature part, you just get sure, you get confirm that this compound has functional group or not. If the compound has no functional group, then numbering from the branches side, and if the compound has functional group, then numbering from the functional group sides. So I am going to give some questions based on nomenclature part that is important for you. I have taken this question, this is very very important questions, so that there will be no confusion. Normally hydrogen will be given along with carbon, so I will suggest avoid hydrogen first. The compound is, suppose the compound is this, first is, you have to write IUPAC name of this compound. This compound. Second is this compound. Here hydrogen is also filled. So I suggest you avoid hydrogen. After writing its name, you put hydrogen. Next is this. And here hydrogen like this. Next is this CH3, CH3, CH3. Actually, it is the CH position of filling of hydrogen make it bulky and confusing for you. So better that you avoid that. You take one functional group bond also. Like this, avoid hydrogen. I suggest you avoid hydrogen. Like this. This. Here is Cl. Here is Cl. Then one more compound like this. This is the compound. Then one more compound. This. So many are there, so I am just going taking example of one functional group, so that when you get question in the exam will be very relaxed that I have done this part. Suppose this is that. Here I have not filled hydrogen. You can fill hydrogen, but better first you give the name and then you fill hydrogen. Here, see, now guess carbon chain is this. Now I am going to remove hydrogen. Better. You remove hydrogen, it will be easy for you. This is 1, 2, 3, 2 dimethyl propene. Now after that you fill hydrogen. There will be no issue. Here also. You can write 2-methyl butane. Here, numbering from the double bond side, propene. Here, 1, 2, 3, 4, 5. Just remove hydrogen. You feel that it will be easy to write. And then you put fill hydrogen. Don't leave it like this in exam. After writing its name, you fill hydrogen. How to fill? You know that. Carbon fulfill its tetravalency, so one bond is there, so 3 hydrogen. Here 1, 3, here 1, 3, 1, 3, here 4 bond, no hydrogen. So like this you will fill. So this compound is 2,2-dimethyl pentane. This compound 2-butyl. This compound here numbering C, longest carbon will be this. Mind it, this is the longest carbon. So here 3-methyl 1-butyl. Here 1, 2, 3, 4, 5, 6. Chloro is used as a prefix, just like a methyl it is used. So 2, 3 dichloro, then hexane. Here this is the longest carbon chain. No branches are there. It is very easy. 1, 2, 3, 4, 5, 6, 7. You can simply say heptane. Here numbering from this side. So 4,4-dimethyl pentanal. Here 2-pentanal. Because O is on the second carbon. This is from first 1, 2, 3, 4, 5, 4-methyl pentanoic acid. So in this way we can write IUPAC name of the different compounds. I have given maximum questions, difficult question, easy question, all type of nomenclature I have explained. I don't think you'll get question difficult than this part. So if you write all the names that I have given in the video, then I hope that you can easily solve question, board question, because I have given the difficult part. I have selected some question from ICSE, from CBSE, all the mixture of the question I have given. And one more information comes in the exam, that find out or identify the functional group. Questions comes, identify the functional group present. So if CHO is there, you can say this is aldehyde group. If COOH, this is carboxyl group. If OH is there, this is alcoholic group. If CO is there, there is ketonic group. If Cl is there, there is a halo group. Double bond ene, triple bond ine. So you have to either identify the functional group or you have to write alkyl group also. Suppose there is a question C3H5OH. Here the question will be identify the alkyl group and the functional group. So alkyl group is this C6C3S7 OH. So this is the functional group. This is the functional group. This is alcohol and its alkyl group is propyl. That's why it becomes propanol. So one question will come from the find out functional group and alkyl group. One question will be from the naming. One is the molecular formula, a structural formula. So in this way we can find out the IUPAC name of the different carbon and its compound. After that, there is one more very important part. Very less questions comes in the board exam, but we cannot say that you won't get question from that part. That is isomerism. Very important part. Isomerism, very important. So I am going to explain isomerism, its types, and I am going to give little bit in detail, and just to check the sample paper of the respective board. Every year boards, CBSE, ICSE, release a sample paper and it shows the pattern of the questions, what type of question is going to come. So I suggest you that you just take out that sample paper and accordingly you just get idea that it's standard of the paper, and accordingly you do. So next part is isomerism. Suppose I am using two examples. This is butane and this is 2-methylpropane. This is butane, this is 2-methylpropane. If you write its molecular formula, then it is C4H10. It will also be C4H10. Feel hydrogen? C4H10. So they have same molecular formula, but different structural formula. Structural formula. Such type of compounds are called isomers. So we can say that butane and 2-methylpropanes are isomers. So you can say that two or more than two organic compound having same molecular formula and their structural formula is different is known as isomers. So, and the process is called isomerism. The first part is chain isomerism. Second part is position isomerism. Third is the functional. Only these three are going to be asked in the board exam: chain, position, and functional. So these are, we are just changing the carbon chain, making short or long. So this is the chain isomerism. For example, question is find isomers of butane. So butane will have only two isomers. One is the butane and second is 2-methyl propane. Second is find isomers of pentane. Suppose you have to find isomers of pentane. So pentane has 5 carbon. You can, this is, and the last is this. So 3 isomers formation and all are kept in the category of chain isomerism. Chain isomerism is a compound, is isomers over there. Carbon chain is involved in the formation of isomers. So we can say pentane has 3 isomers. Similarly, we can find out isomers of hexane also. Now, second is the, suppose this compound. Here, the position of functional group is the first carbon and here the position of functional group is the second carbon. So this type of isomers is known as position isomerism. Very, very important. Position isomerism. Functional isomerism is also not in your syllabus. I don't think it is in syllabus. But I will explain. As I have written, I will explain. So position isomerism is the changing the position of the functional group and we get the isomerism. And third one is the, suppose this is the compound and one more compound here that is not in the syllabus, ether group. If you see the functional group, if you see the molecular formula, then you find C4H9O. Both have the common molecular formula, but they have different functional group. So these are the functional isomerism. You must remember that aldehyde and ketones are the functional isomers. Alcohol and ethers are the functional isomers. So in this way we can get different functional isomers and we will solve the question based on that part. So I have explained about all the part related with this. Only one part is left, that is preparation part and chemical properties part of the hydrocarbon. That is very, very important. For example, methane, how can you prepare methane in the lab? Their properties, ethane, alcohol, the preparation and properties part are left. That I will explain in the next video. I hope the information that I have given to you related with carbon its compound, or you can say related with organic compound, is going to help you to enhance your knowledge. Thank you.